Alright guys, so over the next couple of days we're going to be practicing or reviewing um, a concept from Algebra 1 called factoring. It's going to be very important this year, not only in this unit, but when we get into rational equations and rational functions and stuff like that. Alright, so the objective is that students will factor polynomial expressions when a equals 1. So we're going to deal with the easy ones today. And then what are the steps to factoring polynomial expressions when a equals 1? Alright, so a equals 1 means I just have x squared like I have here, here, or y squared like I have here. Okay, there's an invisible 1 here. Alright, now the way that this works, and you don't have to do this when a equals 1, but I'm going to show it for this first one just because I want you to understand what we're going to be doing tomorrow. Okay, and it's still the same thing. So there is a 1 here, okay? So what we're doing is we're going to take and multiply the leading coefficient, the first coefficient, and the last term. So 1 times 16 is equal to 16. Alright, so then what we need is we need factors of 16 that are going to add to 10, that middle number. So factors of 16, 1 times 16. Well, 1 plus 16 is 17. Okay, so we have 2 and 8. 2 plus 8 equals 10. There's my pair. So my factors for this are x plus 2 and x plus 8. Now, when there's a number other than 1 here, there's another step that has to happen. It doesn't matter in this, because if I put 2 over 1 and divide by that 1, 2 over 1 is still 2, 8 over 1 is still 8. So it's not going to affect these. It will affect them tomorrow, and you'll see that tomorrow. Alright, so right here. So we want factors of 3 that add to negative 4. Okay, so we need factors of 3 that add to negative 4. Alright, well 3 is a prime number. Its only factors are 1 and 3. Well, if I add 1 and 3, I get positive 4. I need negative 4. So whenever I have something like that, where I'm off by a sign, so this is positive and that's negative, then that just means I have to change the signs of my factors. So instead of them being positive 1 and positive 3, I need them to be negative 1 and negative 3. Because negative 1 plus negative 3 is equal to negative 4. So my factors are x minus 1 because it's negative, x minus 3 because it's negative. Alright, so we got y squared plus 13y minus 30. Alright, so we need factors of negative 30 that are going to add to positive 13. That's what we're looking for here. Now, since this is negative, that means 1 has to be positive, 1 has to be negative. Now, a couple things that you should be able to understand by the sign here. If this is going to be a positive number here, then that means that my positive factor should be bigger than my negative factor. And the reverse is also true. The opposite is also true. If this is negative, then my negative should be bigger than my positive. So in this case, though, I want the positive to be bigger. So I'm going to start with negative 1 and 30 so I don't miss any. Well, negative 1 plus 30 is not 13. So negative 2 and 15. Negative 2 plus 15 is 13. There is my pair. So y minus 2, y plus 15. Alright? Now, all can be done this way. Every single one. But there are some special ones that, if you understand how to factor them, they become that much easier. We're going to discuss some of those. Alright, so we got a bunch here. I may not go through all of them, but honestly, they're not that bad. Alright, so the key to all of them is that this last number right here, they all have something in common. No, that's the same as that other one. 25, 36, 9, 9, and 100. And that they are perfect squares. So when you see that they are perfect squares, think about what the square root of them is. The square root of 25 is 5. Right? So this, we know, is made up of 5 times 5. Okay? Then, what you want to think about is either that they add to that middle number, or that they subtract and become 0. Well, if they add to the middle number, like 5 plus 5 is 10, perfect. X plus 5, x plus 5. Now, they're plus because of that. Alright, so let's try the next one. So right here, 36, square root of 36 is 6, so that means it's 6 times 6. Well, 6 plus 6 is 12, that's minus, so it's going to be x minus 6, x minus 6. Okay, so 9, square root of 9 is 3, so 3 times 3 is 9, 3 plus 3 is 6. So this is x plus, because of the plus, 3, x plus 3. You can also write these as x plus 5 squared, x minus 6 squared, x plus 3 squared. Alright, so same thing applies. Square root of 9 is 3. Now I have no middle term, so when there's no middle term, 3 minus 3 is 0. Perfect. So that means it's x, and the key here, because that is minus, which means to equal negative 9, one has to be positive, one has to be negative. Whenever you see this, it's called the difference, subtraction, of two perfect squares. So if you're subtracting, if you have an x squared minus a perfect square, it is always x plus the square root of perfect square, x minus the square root of the perfect square. So same thing here, x squared minus the perfect square of 100. So it's x plus the square root of 100 is 10, and x minus the square root of 100 is 10. Alright, so that's the lesson. You'll have some problems to go with it. If you have any questions, let me know. Just email me.